This is Morales High School's Algebra 1, Semester 1, Practice Final Exam. Yeah, so I found this online and felt that this is one good example. It's not complete, it's not perfect, but it is pretty good, and there are things, and it's all about practice, and the more practice we do, the better we become and the more prepared we will be for whatever comes our way, because we don't know what that placement test for high school Algebra 1 to test out of Algebra 1 and into geometry is going to look like. So the best we can do is we can prepare ourselves by practicing lots and lots of different examples. So this says, what is the opposite or the additive inverse of negative 8y? So we want to know what the additive inverse. So what would we add, which would be the inverse operation of subtracting 8y would be adding 8y. So whoops. So it would be plus 8y. Okay, that would be the additive. So additive, hi, it's right there, spelt right. Additive inverse equals, it's two things that add up to 0, and the multiplicative inverse are things that multiply. So they add to equal 0, and they multiply to equal 1. So the multiplication division inverses, they multiply to make 1. The additive subtraction inverses add to make 0. You're isolating the variable. What is the solution to the equation 64/7 times x equals 8? We are going to multiply by the reciprocal, because we have a fraction. We would not divide by 64/7. We would multiply by the reciprocal, which is 7/64, and we would not multiply 7 times 8 and get 56/64. We're going to simplify first. We see that this 8 is in the numerator, goes into 64 in the denominator, and that makes it super easy that we end up with 7/8. No calculator needed. Positive 7/8. So the answer is going to be A. We want to be efficient. We want to be strong with our number sense and multiplication, times tables, division, divisibility rules. So we have y to the 4th, and it wants to know what that equals when y is equal to -2. You cannot write it. So this is going to equal the quantity of -2 to the 4th. It does not. You would never write it like this. This is wrong. That's an improper. That's written improperly. This is wrong. That's the incorrect way to write the notation. This is the proper one. We have -2 times -2 times -2 times -2, because we have y to the 4th. So we have 4 y's multiplying itself, and if each y is -2, we would end up with that. So positive 16. We have an even number of negatives. We'll cancel to make a positive. Why is my board not working? Number 4, we have, what is the simplified form of 3y plus 5 minus -8y plus -11? We're always going to get rid of these double signs. Drives Mr. McCausland crazy. So we have 3y plus 5. The opposite of -8y is positive 8y, and the positive -11 is still -11. Positive negative, make a negative, negative negative, make a positive. All we're doing is substituting those values. Instead of writing 2, we write one of them. And now we're going to combine like terms. We have 3y and 8y, which makes 11y. and then we have positive 5 and negative 11, which makes negative 8. Whenever you write your simplified expression, you're always going to put your variable first. That's called standard form. So the correct answer is C. Which equation is equivalent to 3x minus 4 times the quantity x minus 4 equals 12? So I'm not solving it. Looking at the choices, I'm not solving it. I just got to see which one is equivalent to it. So if I was going to start simplifying this problem, I would distribute the negative 4 into the parentheses. And that next line would look like 3x minus 4x plus 16 equals 12. We have negative 4 times x, which is negative 4x. And we have negative 4 times negative 4, which is positive 16. So that looks like D. And then if none of the choices are there, I would continue to simplify until I have one that looks like one of the 4 choices. What is the solution to the equation? So this one I am going to simplify completely. Wants to know what h is equal to. So I have 6 times the quantity 2h minus 7 equals 3 times the quantity 5h minus 4. I'm going to distribute, and I'm going to distribute. So 6 times 2h is 12h. 6 times negative 7 is negative 42. 3 times 5h equals 15h, and 3 times negative 4 is negative 12. I have variables on the left and right sides, and I have constants on the left and right sides. I'm always going to move the variable first. I'm going to move the variables first. So I'm going to move the negative 12h over, or the 12h over, by subtracting 12h. These cancel. You're left with negative 42 equals 3h minus 12. And now this is a nice simple two-step equation. So we'll get rid of the things being added and subtracted first. And then we'll get rid of the multiplication. So it leaves me with negative 10 equals h. H equals negative 10. Let's look. That would be A. Number 7, given the point 6, 10 and 3, 4, what is the y-intercept of the line through the points? So I'm given 2 points. If I'm given 2 points, I can find the slope. So the y-intercept of the line and 2 points. So I'm going to use slope-intercept form to get me the y-intercept, because that would be the B part, if I could figure that out. So given 2 points, I'm going to find the slope, and I find the slope by using the formula y sub 2 minus y sub 1 over x sub 2 minus x sub 1. This would be x sub 1, y sub 1. This could be x sub 2, y sub 2. And this just means the x value in the first point. This just means the y value in the first point. This means the x value in the second point, and this means the y value in the second point. So with this equation, I want the y value in the second point, which is 4, minus the y value in the first point, which is 10, over the x value in the second point, 3, minus the x value in the first point, 6. 4 minus 10 is negative 6. 3 minus 6 is negative 3. And that gives me positive 2. Now this is the slope. So that's all I was able to get. But I have this equation, y equals mx plus b, where m equals the slope, b equals the y-intercept, and x and y are a point. So here's the interesting thing. What have I been provided? I have the slope, so I can fill in for slope. I know what the slope is. 2 is going to go there. I don't know what the y-intercept is. That's what I'm looking for, the y-intercept. So I need to find the y-intercept. And then I do know, so I'm looking for the y-intercept, sorry, I'm going to look for this, I'm solving for this, but do I have a point? Yeah, in fact, I have 2 points. I have a first point and a second point. I'm going to just use 610, and I'm going to plug in the x and y value for the point 610 in there. So, okay, if I have the point 610, 6 is my x value, 10 is my y value. So when I look at this equation, y equals mx plus b, let's do this too. Let's highlight this, what we're going to do. So my y value is 10 equals my m value is 2, my x value is 6, and I'm looking for my b. So now I'm going to simplify, and now I'm going to move the 12, and I get negative 2 for b. And this represents my y-intercept. So the y-intercept is negative 2. b equals 2. And they sort of alluded that we would use that because they said b. Which ordered pair is a solution to the equation y equals negative 2x plus 1? So I have this first point, negative 2, 3, that's my x and my y value, and I have an equation y equals negative 2x plus 1. If it's a solution, when I substitute the values in, it should be a true statement. Unfortunately, I don't get that. I get 3 equals 5, and that's not true. So this is not a solution to that equation. So we go through, and now we do point B, which is negative 3, 5, and we do the same thing using the equation, plugging in 5 for y, negative 3 for x, and simplify. 5 equals 6 plus 1. 5 does not equal 7, so I know this point is not a solution to that equation. And now we move on to the next point, and we're going to keep doing this until we get a statement that is true. So y is 5, x is negative 2, so 5 equals 4 plus 1, and yes, 5 equals 5. That's a true statement. So if it's a true statement, that means this is a solution to that equation. Which is the first incorrect step in the solution shown below. So let's take a look. So this is the problem that we're starting with. This is the problem, and our step 1, I would distribute. So if I distribute it, I would get 3x plus 3 minus 4 equals 2. So this step from here to here is okay. Step 1 is okay. And now I would combine like terms. I have positive 3 and negative 4, which makes negative 1. So I found my mistake. So where's the mistake, which is the first incorrect step? Is going to be step 2 is incorrect. That should be a negative 1. All right, that's pretty easy. Number 10, what is the solution to the inequality 8 minus 2x is less than 12? So we're going to simplify. We're going to isolate the variable. Just like if it was an equation, this is an inequality. So it's a two-step. We're going to move the constants. That leaves us with negative 2x is less than positive 4. We're going to divide both sides by a negative 2. And whenever we multiply both sides of an inequality by a negative, we must flip the inequality. It goes from less than to greater than, and then 4 over negative 2 is negative 2. So my solution is going to be x is greater than negative 2. That's going to be C. And the reason why you flip the inequality is because when you multiply, when you change the sign of your variable, you're moving it across the inequality. So when we move it across, if it's sitting on this side, it's less than, and then when I move it to the other side, if it's here, it's now going to be a greater than. Because if your variable moves from there, from negative to positive, moving it across, add x, we notice that we move it across the inequality. So that's the idea of why we flip the inequality when we multiply or divide both sides by a negative. What you're doing is you're just moving that variable across the inequality. Evaluate negative x to the second when x equals 4. This is that example, very similar. So when we plug in 4 for x, there are no parentheses. You have this exponent. It's 2. The base of the exponent is x. The negative is outside of it. So if we really wanted to see what was happening here, this is the opposite of x squared. So this says the opposite of 4 squared. That's why this answer is negative 16. Tricky problem. Lots of students make that mistake. They misinterpret it for negative 4 times negative 4. That does not say negative 4 times negative 4. If we wanted to see the quantity of negative 4 squared, would need parentheses. And that would be negative 4 times negative 4. So completely different. This is way, way different. Different question. So be careful and understand the difference between parentheses and no parentheses. Which inequality is equivalent to 6x minus 8 is greater than 4x plus 3? We have variables on both sides and we have constants on both sides. So we're going to move the variables first. Remember how I said move the variables first. You have 2x minus 8 is greater than 3. We're going to add 8 to, we're going to add 8 to both sides. That leaves us with 2x is greater than 11. And we have 2x is greater than 11, so that would be B. So we would just keep going until we see a statement that looks similar to number 12. If your cell phone plan costs $30 each month and 20 cents per minute, which equation would determine how many minutes you used in April if your total bill was $45.60? So look, our total bill is going to be the usage per minute, the per minute cost, plus your monthly cost. So the total, we know what the total is. The total is going to be $45.60. The per minute part is right here. It's 20 cents per minute. That's the P value. And then the monthly cost, which is right here, costs each month. So we're only talking about 1 month. So the total is going to be $45.60 equals, it is going to be 20 cents per minute plus our monthly surcharge. So $45.60 equals 0.2 minutes plus 30. That's going to be B right there. And it can be on either side of the equation. What is the x-intercept of the equation? So we've talked about intercepts quite a bit. When we have intercepts, if it's the x-intercept, let's not do that. If it's the x-intercept, let's do this, and let's do this color. If this is an x-intercept, we notice that it's going to lie anywhere on the x-axis. So if I give you a whole bunch of those, if we look at any x-intercept, what's going to be consistent with it? That's going to be like negative 7, 0. This is going to be negative 2, 0. This is going to be like 3, 0. This could be 6, 0. And what do we notice on all x-intercepts? All x-intercepts have a y value that equals 0. Notice y equals 0, y equals 0, y equals 0, because that's what put it on the x-axis. So we know that when we're looking for the x-intercept, we're going to plug in 0 for y. So 5x plus 3y equals negative 15. If we're finding the x-intercept, we're going to plug 0 in for y. So this equation now becomes 5x plus 3 times 0 equals negative 15. And that's 5x plus 0 equals negative 15. And that's 5x equals negative 15. And we would divide by 5, x equals negative 3. So my x-intercept is 0, no, my x value is negative 3 when I plugged in 0 for y. So I plugged in 0 for y, and I got negative 3 for x. So if I was going to write that as a coordinate, I would write it as negative 3, 0. Which line is the graph 6x plus 4y equals 12? So as I mentioned earlier, if we have this is standard form. This is called standard form in linear equations, standard form. And standard form is when you are in this format, ax plus by equals c. And we use that to find, it's really conducive for finding the x and y intercepts. It's super easy because if we're finding the x-intercept, let's go down a little bit. So 6x, I think it was plus 4y, equals 12, and 6x plus 4y equals 12. So if I'm finding the x-intercept, I plug 0 in for y, and what happens?
Good afternoon. Clarissa J., if you're on campus, could you please report to classroom 3A? Thank you.
So if you see this, right, what's going to happen to this term? Well, it's going to be multiplied by 0, and what happens? It goes away. It's equal to 0. So you're only left with 6x equals 12. So that's easy to solve for. So my x-intercept is going to equal 2. And if we wanted to find the y-intercept, we know that our x value is always going to be 0. And what's going to happen to this term right here? 6 times 0 is 0, and what are you left with? Just 4y equals 12, and that's easy to solve. So my y-intercept equals 3. So I have my two intercepts. That's not a coordinate. Do not write 2, 3. Those are the x, where it crosses the x-axis at 2. So let's x-axis at 2, x-axis at 2, x-axis at 2, x-axis at 2. Well, we don't have to move on because no other graph other than B has those share the points. But let's just make sure my y-intercept is 3. My y-intercept, y-axis is 3, y-axis is 3, y-axis is 3. So that's kind of close. D was kind of close, but the correct answer is B. That is the graph of the equation. The other way you could have done this is you could have definitely done 6x plus 4y equals 12, and you could have put it in slope-intercept form, which is y equals mx plus b. So you can solve for y. So we could subtract 6x. You can get 4y equals negative 6x plus 12. You can divide everything by 4. And you get the equation y equals negative 3 halves x plus 3. So my y-intercept equals 3, and my slope equals negative 3 halves. So 3, y-intercept of 3 is still this, and my slope of negative 3 halves is down 3, 1, 2, 3, right 2. And it still takes me to there, and that would be also another way you could have done it. Number 16, what is the slope and y-intercept of the line 3x plus 5y equals 8? So we are again in standard form, and we are going to convert it from standard to slope-intercept by isolating y. We're going to subtract 3x. We get 5y equals negative 3x plus 8. And we are going to divide by 5. We get y equals negative 3/5 x plus 8/5. And that means my y-intercept is 8/5. And my slope is equal to negative 3/5. So which one of those has that? Slope of negative 3/5, y-intercept 8/5. Negative 3/5, so that is C. Number 17, what is the solution of the systems of equation? So systems, there's multiple ways that we can solve systems of equations. Substitution, multiplication, multiplication and addition. I'm going to use substitution here because this equation, this bottom equation, is really close. If I add 3x to both sides, that equation now becomes y equals 3x minus 2. And I'm going to substitute this in for y in the top equation. So I have 9x minus 3. Instead of writing y, I'm going to write what y is equal to. That's the quantity of 3x minus 2, and that equals 6. So I'm going to simplify this. Notice both of these equations have two variables, so I can never solve for it. The nice thing about substitution is, in this equation, I now only have one variable. So that's 9x minus 9x plus 6 equals 6. All I did was distribute the negative 3 into both of those. These are going to cancel, and you get 6 equals 6. When your variables cancel and you and you make a true statement, the answer is all real numbers, meaning every number would be a solution to the system. So what is it? Well, it's all points on the line, but it's infinite many solutions. Infinite solutions. I don't like that answer because we don't care if there's 1, 2, infinite, none. I want to know where it is, because notice you're given a location. I think this is hypocritical of answers. It should be a location, and where are the solutions? All the solutions are on the line. So, but I got to go to a lot of conferences to explain that answer and convince people. So at the moment, it's infinite many solutions. All right, 18, there were 422 people at a play. Admission for adults was $6 and $3 for children. The receipts were $1,656. Which system below would be used to discover how many adults, A, and how many children, C, attended the play? So we have two statements that we have to write. This 422 people deal with adults and children. This 1,656 deals with the cost. So we have one statement which is on participation or population, participation, and that's people. So there were 422 people, and that consisted of A and C, where A is the number of adults and C is the number of children. So C represents, so these are people, and people should equal the total people. And then cost is the other equation. So they were able to charge 1,656, and okay, how do we get? Well, we know adults were $6 per adult, so we would take 6 and multiply it by the number of adults. And we know that it's $3 per kid, and we would take that cost and multiply it by the number of kids, would give us the total cost. So you're going to have, I think it's B, A plus C equals 422. 6A plus 3C equals 16. Yeah, B. So that's a good problem. That is a very typical Algebra 1 question that you will see. What is the x-intercept of the graph? Well, we know that the x-intercept is where it crosses the x-axis. This is the x-axis. Where does this line cross the x-axis? It crosses it right there, and that looks like it's positive 2. So the x-intercept is positive 2. That's the coordinate 2, 0. Wants to know what your x value is. Number 20. So this is a graph of a linear inequality, and I didn't know if that was an equal sign. I'm going to keep it as an equal sign. It says y is greater than or equal to 2x minus 1. That's a horrible x. So I know that my slope equals 2 and my y-intercept equals negative 1. And so I know, and it's equal to, so I know that my border, so these are borders. This is a border. It's border between true, this is true, and this is false. It's true because that's where we're shading. We shade the true, we don't shade the false. So this border is solid. That means it's an equal sign. If the border was dotted, that doesn't mean it has an equal sign. So I have 2 with a solid border, and I have 2 with a dotted border. Okay? So I know that B, it's not going to be B, and I know it's not going to be D. So now I need to see, okay, I got the left side is true here, and C, the right side is true. So I'm going to pick a point. The easiest point to pick is 0, 0. I'm going to pick this point right here, 0, 0, and I know that it's on the true side. So if I plug in 0 for my x and 0 in for my y, and I get a true statement, that's a true statement, 0 is greater than negative 1, I know that this is the answer. So the answer is going to be A. If I plugged in, right, it says if we plug in 0 and we get true, this is not it, because look at this point right here, 0, 0 is false, but that's not what the equation says. So that's why, oh, and on C too, C is, sorry, that's false also. That's a false. My 0, 0, if it was that graph, it would need to be false, but it says true, so I know that it's that one. It's a good question. Good comprehension of linear inequalities. Which equation represents the line through the point 2, 5 with a slope of 3/2? So we again are going to use y equals mx plus b. We're going to plug in the points. 5 is my y value. My slope is 3/2. So I'm going to plug in that for m. My x value is 2. And then I have my b value, because I got to find out what my y-intercept is. So we get 5 equals 3 plus b, because the 2's cancel. Minus 3, 2 equals b. So now I know that my y-intercept is 2. So that equation now becomes y equals 3/2 x plus 2. So which one of those is A? Right? Yep, A. Good, good. Which equation represents the graph shown below? We again are dealing with linear equations. So I could either pull out the slope and the y-intercept for each of these and see which one it does, or I can go here and go, oh, I see that my y-intercept equals 2, and then, oh, let's also find the slope. So the slope is, remember, equals rise over run. So going from one point to the other, I go up 2, and then I'm going to go to the right 3. So up 2 is positive 2, up is positive, right 3 is positive 3. This is my slope. So which line has a slope of 2/3 and a y-intercept of 2? So that would be D. Finally got a D. It's been a while. We've yet to have a D problem. Answer. Sorry. 23. Which description below best represents the lines y equals negative 2/3 x plus 3 and y equals negative 2/3 x plus 5. So when we have two lines, they can intersect in one point. They can be parallel and not intersect at all. They can be the same line on top of each other. Okay? And that's it. So we can have those situations when they are the same line. When they are the same line, they have the same slope and the same y-intercept because they're the same lines. When you have parallel lines, you have the same parallel. They have the same slope, but different y-intercepts, and that's what makes them not the same line. And here you're going to have different. You can have perpendicular. Sorry about that. Perpendicular. Sorry. Let's do that. They can intersect and they can be perpendicular. When they're perpendicular, their slopes are opposite inverse. Okay, the opposite inverse. So if it was 2, the opposite inverse would be negative 1/2. Those are examples of that. So we look at their slopes. The slopes are the same. So we know they're parallel or the same, but they have different y-intercepts. So we know that they are parallel to each other. They have different y-intercepts, so they're going to cross the y-axis at different locations, but they will have the same rate of change. They'll go down 2, right 3, down 2, right 3. Another outstanding question. What is the value of y in the solution of the system of the equation? What is the value of y? Okay, well, we have two equations. We have this, and we have 2x plus 3y equals 13. I'm going to again use the substitution. I'm going to take this and I'm going to substitute it in for y. Instead of writing y, I'm going to write 4x plus 9. So 2x plus 3 times the quantity 4x plus 9 equals 13. I'm going to simplify. I'm going to simplify on the same side. And now it's a two-step problem. I'm going to move the constant. 14x equals negative 14. Divide by 14, divide by 14, x equals negative 1. So that's my x value. It's not asking for the x. What is the y value? So I can take either of these equations. I'm going to take this one because I want to know what my y is. And I'm going to plug it in when x equals negative 1. So it wants to know when is it. So that's negative 4 plus 9, y equals 5. So the solution, what is the value of y in the solution? That's the solution to the system. The solution is going to be negative 1, 5. That's a point that both of those lines share. But I want to know the y part, so that is C. Really important to understand all the aspects of these questions. You can't just do it because that's how your math teacher did it. You have to understand, what does it represent? What does it mean? If 4 comma negative 3 is a solution to the system of equation, which graph represents that system? Is a solution. So let's find 4, negative 3. So 4 in the x, negative 3. 1, 2, 3, 4. 1, 2, 3. Well, that's not on the line. These are all the solutions, and that's not it. So it's not one of the solutions. 4, negative 3. Kind of looks like it doesn't go through it, so I'm not going to say that one. 4, negative 3. Nope, doesn't cross it. And 4, negative 3. There you go. Okay. So it's a solution, meaning it's on both lines. You notice that that point is a solution to that line, and it's a solution that's on that line. That's why it's a system. Solution to a system. 26. Now we have systems of inequalities. Oh, yeah, right there. Systems of inequalities. Means two inequality equations, and we want to know which graph represents the solution to the system. So let's take this first equation. Y is less than or equal to 2x plus 1. So because it's an equal sign, we know that we're going to include the boundary, and the y-intercept is 1 and the slope is 2. So where is the y-intercept? 1 with a slope of 2, and it's a closed circle, meaning the border is solid, because this represents the border. So 1, y-intercept is 1 with a slope of 2. So that's 1 up 2, right 1 there. That's a solid line. That's good. That could be one of them. Not B. It is not going to be B because that's a dotted line. It's not going to be C because it's a dotted line. It could be D. It could absolutely. It's a y-intercept of 1 with a slope of 2 and a border that is inclusive. Now we got a C. Remember. So in A, what do we know about the origin? What do we know about the point 0, 0? If we plug it in to this equation, what would we expect graph A to tell me? That it's true. So if I plug in 0, is 0 less than or equal to 1? That's a true statement. And that's what it said. So my answer is going to be A because it worked for it. And this says, what does this say about 0, 0? This graph says that it's false, but that's not what we got when we plugged it in. We got true, so we know that this is the graph that represents it. Number 27. 27 says, what is the next step involving the equation? So we have 12 equals 5 minus 3 times the quantity x plus 2. We have to do multiplication, distributive property, before subtraction. Students who do 5 minus 3 are incorrect. We have to distribute that negative 3 into the x and the 2. Negative 3 times x is negative 3x. Negative 3 times 2 is negative 6. So we're going to get D again. Finally, D has been so underrepresented here. 28. Which expression below is equivalent to 4? I have no idea what that symbol means. I have no idea. I don't know what that, I looked it up. I don't know what it means. I don't know. I mean, I circled A. I don't know. 9 is bigger than 7 and 4 is bigger than 3. I don't know. I've never seen this symbol, this tall rectangle symbol in math before. So that, I don't know what's going on. We know that these are the same. Those are two equal values. These are equal. This is smaller, so I don't know. I don't know. Sorry. So that was what I said. 29 I do know, however. I do know my exponents. When we divide like bases, what do we do with their exponents? We are going to subtract them. So you subtract the exponents. The exponents are 7 and negative 5. So make sure you understand that the negative represents the division, and that negative represents the base or the exponent there. So very tricky. A lot of students would just say 7 minus 5, which is incorrect. You get 7 plus 5 or y to the 12th? Y to the 12th is the correct answer. All right, now we have powers of power. When you have a power of a power, you can distribute it into each of the terms, each of the items, and it is multiplication when you do power of a power. Multiply their exponents. So that's going to look like 2 to the first times 3, x to the 4th times 3, over y to the first times 3, which is 2 to the 3rd, x to the 12th, over y to the 3rd, which equals 8, x to the 12th, y to the 3rd. Good one. We again have a power of a power, and we're going to distribute it to each of the pieces. So you have x to the 5th times 2, y to the 1st times 2. That gives you x to the 10th, y to the 2nd. Here, we're going to take pieces together. So you have 4 x to the 6th over 12 xy to the 3rd. You can split these, constants with constants, like variables with like variables, and you can break it up like that. So this is going to be simplified to 1/3. This is going to be simplified to x to the 6th minus 1, and this is going to stay down in the denominator. So we have x to the 6th minus 1 is 5 in the numerator. Then you have the 3 in the denominator and y to the 3rd in the denominator. So x to the 5th, 3y to the 3rd. Here we have powers and then multiplication. So we have to do this exponent first. We have to simplify this exponent before we multiply these two terms together. So I'm going to distribute that 3 into there. So I have x to the 2nd, y to the 2nd. And now I'm going to distribute this into each of the 3 pieces. So I have 2 to the 1st times 3, x to the 2nd times 3, y to the 2nd times 3. That gives me x to the 2nd, y to the 2nd times 2 to the 3rd, x to the 6th, y to the 6th. We can simplify that. That's x to the 2nd, y to the 2nd. That's 8x to the 6th, y to the 6th. Now, when we multiply like bases, we add their exponents. So we're multiplying these like bases, so we will add the exponents. So we get the 8, we get x to the 2nd plus 6, and we get y to the 2nd plus 6. So my answer is 8 x to the 8th, y to the 8th, which is B. And that's it. That's all we got today. So not bad. That's good high school. You should definitely know all those components outside of that weird rectangle thing, and you should be proficient. Good luck.